In this video we're going to look at solving linear simultaneous equations by substitution. Although this method can be used for other types of simultaneous equations too. Just going to mention really what you need to know before you can really apply this method. Assumed knowledge. You're going to have to be confident with substitution. And you're also going to have to be confident with solving simple linear equations. If you can't do either of these two things, then you won't be able to employ this method that I'm about to describe. And this is the case often in maths. When people say they have a difficulty with a particular topic, frequently it's actually not that topic that's causing the problem. It's a prerequisite skill or technique that they haven't mastered that's actually causing the problem. So if you're not confident with these two techniques, you need to look at that first. But anyway, we'll move on. So here we have a pair of linear equations, and we're going to solve these using the method of substitution. There are other methods, but we're going to use substitution. So here we have a pair of linear equations, and we're going to find simultaneously the solution to these two equations. You may ask, what do I mean by a simultaneous solution? It's an answer that satisfies both this equation and also this equation. For example, if I was to look at just this first equation, I can just see very quickly that if I was to choose x equal to 1 and y equal to 1, then 2 times 1 is 2, add 4 times 1, 4, gives me 6. So that would satisfy this equation, x equals 1 and y equals 1. However, if I tried to use that same substitution into the second equation, it wouldn't work. What I would get on the left is minus 7, and that does not equal 3, so it doesn't work for the second equation. I need to find a value of x and y that satisfies this equation and also this equation. So we're going to move through these steps in turn. The first step, to rearrange either equation to give y equals or x equals. So it doesn't matter which equation, and it doesn't matter whether you set the equation y equals or x equals. If you're proficient, then it really won't matter. However, usually sometimes one way is easier than the other, and only experience is going to tell you that. So I'm going to just choose the first equation, and I'm going to rearrange it in terms of x equals. And this is where your proficiency with solving and rearranging linear equations comes in, or simple linear equations. I want the x on its own, so I'm going to subtract 4y from both sides. And then I'm going to divide both sides by 2. And again, hopefully you can see that this is really a fraction with a common denominator, so I can simplify this. And indeed simplify this a little bit more. So this is me having completed the first step. So I'm just going to write this here. I've rearranged this first equation like so. I can now move on to step 2. And that's to substitute this into the other equation. So now I'm going to substitute for x into this other second equation. So again, you should know with substitution, every time I see the value I'm substituting, I simply replace it with the substitution. And as far as substitution is concerned, that's it done really. Step 3 is to solve the new equation. Well, in order to begin to solve it, I'm going to have to expand these brackets. I'm going to collect like terms together. And then I'm going to solve this. I'm going to add 12 to both sides. In other words, 5y equals 15, and then I'm going to divide both sides by 5 to give me y equals 3, and that's the first part of my solution. I've got one of the solutions now, that y is equal to 3. And you can see that the step I've just carried out does rely on algebraic proficiency. So, you know, again, solving linear simultaneous equations by substitution is easy, provided that you've got fluency with being able to solve and manipulate simple linear equations. And so now I'll move on to the last step. Substitute the answer into either equation and solve. So I can substitute this y equals 3 into either of the equations. I'm going to choose the first one. You get the same answer if you substitute it into the second. And now again, here I have got another linear equation that I need to solve, so I'm going to subtract 12 from both sides. And then I'm going to divide both sides by 2. In other words, x equals minus 3. So there I found my other part of the answer. So x equals minus 3 and y equals 3. Now, again, it's always good practice to check your answer. You know, anybody can make a mistake, and nothing's lost apart from a little bit of time as long as you recognise you've made a mistake and correct it. So I can easily check my answers by substituting in to the each of the equations, which I'll do quickly. So 2 times minus 3 is minus 6. Add 4 times 3 is 12. So minus 6 add 12 gives me 6 as expected. Minus 4 times minus 3 gives me plus 12. Minus 3 times 3. So 12 minus 9 gives me 3 as expected. So I know for certain that these answers are correct.